Trig functions, 5.2. Right now we are figuring out the hypotenuse. Everybody got it? It is a number. You are very correct. And a real one, in fact, not even a complex one. Probably not. Square root of what? 145. Okay, so 72 and 60, sorry, 81 and 64, yeah, 145. Okay, so if I were to ask you what is the sine of angle X, it's opposite of our hypotenuse, right? So 9 over root 145. Do you know how to simplify that? Pull your heads out of your butts, you do. Okay, we have to get rid of this as a denominator. Is this ringing any bells? No. Multiply by root 145, top and bottom. And I don't think we can simplify that one, can we? $145 divided by 5 is 29. Yeah, we're good. Okay, what's cosine of X? Over. Okay, simplify it. Yep. That is ugly. Okay, there's cosine, sine, and what's tangent? Okay. Ringing bells, ding, ding. Fortunately. Okay, we're going to add a few more of these. We have something called secant. Yeah, and here does that because he knows what's coming. Okay, the secant X is reciprocal of cosine. So what's cosine? Yeah, you just flip it over. Okay, so you can also write it as 1 over cosine. Okay, either way works. It doesn't matter to me which you use, but so with this triangle, what's the secant of angle X? H over A. Somebody please rescue me. Thank you. Okay, now cosecant. I should probably write these out. This is secant. Okay, this is cosecant. And it is the reciprocal of sine. So it is what? Yep. Or 1 over sine. And we get 145 over 9 here, right? I bet you can't guess what cotangent is.
No idea.
A over O.
Or 1 over tan. So A over O is 8 over 9. Okay, so now you have 3 new ones to remember. Secant, cosecant, cotangent. Wow, better get to work in then.
How do you do it with calculator?
You have to put that in.
Lovely.
In the calculator, you put 1 over cosine of whatever. Okay. So that's a great question. These, the thing I see get mixed up the most is that secant, you want to put secant and sine together. No, okay, secant and cosine go together. That's the biggest mistake. So secant goes with cosine, sine and cosecant go together. Okay, I have no idea why they labeled that way. I probably done it differently, but that's what it is. And then cotangent is pretty obvious. So are you okay with those? Okay. No answer. Are you okay with those?
Yes.
All right. So here's some things you might run into. If cosine theta equals 3/4, find secant theta. That one's easy. Theta. Oh, yes. Remember, we're going in the Greek alphabet now? So, as if English alphabet and math wasn't confusing enough, we're adding Greek now. This is called theta. It's a circle with a line through it. We use that letter a lot. Okay. Yeah. A lot.
Yeah.
Theta. So if cosine is 3/4, what's secant? Thank you, Jared. Why? Yeah, they're reciprocals. Cosine is 3/4. You just flip it over to get secant. You feel like it should or it should? I don't disagree. If I showed you the basis of math, it's called math logic. We might have this discussion last week. It is literally a language. I can show it to you. But it would probably make you vomit. Okay, can you take this information and figure out the other 4 trig functions? Huh? Flip it over. Flip it over. So just like we did up here, can you use that information to figure out the other 4 functions? Okay, how are we going to do it? Yep. If that's theta, we have adjacent over hypotenuse, right? Pythagorean theorem gives us opposite. Okay, can you get the other functions from that? If this is root 7, you can write out the other functions because I've shown you an example. Okay.
Hey, whoa.
Yeah, this is A, and this is H. Okay. All right. Do you remember the special right triangles?
So,
Who's special? Okay, what are the angle measures of that triangle? That's a special right triangle. We know this. If that's 5 inches, so is that one. Does anybody remember the ratio for the third one? No, I mean for the hypotenuse. You can use the Pythagorean theorem here, or you can just know that it's whatever times root 2. 5 times the square root of 2. I use that a lot in woodshop, actually. Yeah, it's 5 times 1.414. And if I'm going from the other direction, it's 5 divided by 1, or divided by 1.414. Okay. They make your life easier. No, easier. This is a 30, 60, 90. 4, 8 is correct on the hypotenuse, so it's 2 times 4. This one is 4 root 3.
what is that, an 80 at the top? Oh.
30, 60, 90.
I thought it was
80, 60, 90 is not a triangle.
I don't know what triangle it is.
I think you need to start thinking again there.
I never knew that there was no stuff.
Yes, you did. I could probably pull a test out of this cabinet that shows you did. Yeah, that's what I thought. Okay, those are just something you have to work with. Yeah, they're all in there. Okay, last item. This is something that's gonna you all have a calculator? If you don't have one, get one. No. Yes, theta and sine theta on top, 30, 45, and 60 down the side. Okay, number 1, what do we make sure? The calculator is in what mode? Degree mode. Because I have a calculus class. We work in radians a lot. Always, actually. You guys are going to learn what radians are here in about a month. We have to. Go to mode. Hit enter on degree. Okay. What's the sine of 30? Okay, we're going to start writing those as fractions. Okay. What's the sin of 45? Does anybody know the fraction equivalent? Okay. Okay, root 2 over 2. Now check this out. Sine of 45. Okay, opposite over hypotenuse. And it simplifies down to this. Okay. And I believe 60 is 0.866, which is root 3 over 2.
You can do the same thing for cosine and tangent. They're in your book. So if you turn to page 287, there's a table of ratios there that you can use. We'll get into using these more, but for now I just want to introduce you to it. We're basically, instead of using the decimals, we're using the fractions. Okay. And they come straight from, you are going to need an ice pack. They come straight from, oh, my red pen is broken. Those special right triangles. Okay, sine of 45, 1 over root 2 simplifies to that. So take a look at those. We'll use them quite a bit the next few weeks. Any questions? Okay.